for our fourth and final example. We don't need to do any rearranging because the y is already isolated, but we need to go through and identify our vertex and our transformations. So vertex, in with the x, we have a +3, so that means I'm going to shift left 3 to -3. There's nothing being added or subtracted here, so that means there's no vertical shift, so it starts at 0, okay? So shift left 3, it doesn't shift up or down at all. Right, the a value is positive, so this is going to open up. And then 5/2, well, it's a fraction that's bigger than 1, so this is going to be a steeper or narrower graph. Than the parent function. Okay, so our vertex is at -3, 0. -1, 2, 3, 0 is over here on the x-axis. It's an x-intercept. And I have a rise of 5 and a run of 2, so I'm going to go up 5 points and over. Up 5 over 2 will give me this point right here. And then I don't really have enough space to continue going, so this one I'm only going to do 3 points, and that's okay. So the other one I'm going to go back up 5 and backwards 2 to right here. Okay, and then I'm going to draw my absolute value lines in. So there's my graph. And again, how would this change if it was an inequality? So this inequality down here has an equal to, so it's still going to have a solid line. And I've got y is greater than something, y is greater than or equal to, y is more. So that means I'm going to shade above the absolute value graph. All right, here we go. So I'm still going to have a solid line. Here's my vertex point. Go diagonal up. Again, make sure you plot points when you're drawing your inequalities. I'm just doing it real quick based on what we already had. And we want to shade above. Above the vertex is inside, so I'm shading everything inside this absolute value graph, okay? Think about it in terms of above and below, not inside and outside. All right, so everything on the absolute value line, in addition to in this shaded area, would be a solution to this inequality.